My name is Dror Sapir, and this is my presentation for Lab 2, Geometrical Approach to Gaussian Beam Profiling. So why did we do this lab? We did this lab to characterize and analyze a Gaussian beam. Gaussian beams are beams that have an amplitude profile of Gaussian functions. Our purpose for this lab was to analyze the beam by locating the Rayleigh range and then taking measurements before and after that minimum beam waist. We did this by using a knife edge to gradually block the beam systematically while recording the effect that this movement has on the radiance of the beam. The beginning of this lab was essentially the end of the previous lab. I started by aligning the beam and microscope through an optical rail, as was done in Lab 1. After going back and forth through the rail and confirming that the halo and crosshair were both stable, I turned off the laser and focused on the surface of the laser tube. I then moved the microscope to a new position and placed the knife edge where the crosshairs were virtually located. The photodiode was then placed behind the knife edge to record the portion of the beam that goes past the blade. The location of the knife edge on a translation stage was recorded at 10.84 millimeters. From there, I moved the knife into the beam in increments of 0.02 millimeters at a time and recorded the irradiance, which was calculated from voltage that was shown. The same procedure was done on the other side of the Rayleigh range to give a complete data set of the beam. The lab also called for repeating this procedure on both sides of a minimum beam waist after going through a lens, which I didn't have time to finish. So these are the results for the part that was not using the lens. These two graphs were made from the data and show the radiance versus the position for the first location and the second location on both sides of the Rayleigh range. In conclusion, the difficulty in this lab was similar to the last lab, which was the time constraint. Overall, I believe the numbers made sense. I haven't fully analyzed them yet, but the fact that they make sense can be deduced by connecting the two graphs, flipping one of them and connecting them, which would produce something very similar to a Gaussian function. And that's why I believe overall my data is sensible.